Hello everyone, here I am going to explain about operating system assignment 2. My topic is first come first serve scheduling. Here I am going to explain my topic. This is the index and this is the titles. Introduction, experimental setup, implementation setup, flow chart and complete code, observation and comparative evaluation. Next I am going to explain about introduction. So CPU scheduling is a method an operating system uses to devise which process runs first. When multiple processes are waiting for a scheduler to pick the best one based upon the algorithm, the goal is to improve the CPU efficiency, fairness, waiting time, and turnaround time. So the use of FCFS means first come first serve it is an simplest scheduling algorithm, and the process that arrives first is executed first. It follows queue structure. There is no primitive. Once the process starts, it runs until the completion. Objective of our project. So here are the objectives of the project: to design and implement and evaluate FCFS scheduling, to collect waiting time and turnaround time and response time, to run FCFS on multiple database and compare results, to decide whether FCFS is scheduled for real-time system. Next is the experimental setup. Programming language used Python, simple, clean, suitable for the simulation based problems. Next, tools are used. Programming online Python compiler allows quick input and output testing. Database description, here we are used three database 1 process with the different arrival time and burst time, database 2 all process arriving at the same time, and database 3 large burst time variations. Next, these are the database 1, database 2 and database 3 at a different arrival time and burst time. Next, here is the implementation setup steps. Next, step 1 is to input the number of the processor. The user enters how many processor will be stimulated. Step 2, enter arrival time and burst time. Each process has arrival time and burst time. AT means when it arrives, BT means how long it needs CPU. Next, third step is processors. Sort processors based on the arrival time. Next, CPU timeline begins. It means step 4. If the CPU is idle, wait until the next processor arrives. Execute the process in order of arrival. Next, calculate matrix. Calculate matrix means starting time, completion time, and turnaround time, and waiting time and response time. Last is to print the table. A clean table is generated using Python. Next, observation. This is the flow chart of the topic. First it starts. Next, the user will input the processor, the arrival time. Next, sort by the arrival time. Next, calculate CT, TAT, WT and RT. Next, generate Gantt chart. Next, display result and end the program. Here is the complete code of using Python language. The observation that is observed here is waiting time and turnaround time and response time and CPU behavior. Waiting time means how long the processor wait in the queue. Turnaround time means the total time taken from the arrival to completion. Response time means the time from the arrival to the first CPU response. CPU behavior. FCFS can cause long waiting time if the long process comes first. CPU can become idle if the next process has not arrived at. Next, this is the output of the data set 1, and this is the output of the data set 2, and this is the output of the data set 3. I will run the program at last. This is the comparative evaluation. Database 1 arrival time is 3.33, and average TAT is 8.67. Idle time is low, and it is simple flow. Next, database 2 arrival time is 5.75, and average TAT is 10.5, and idle time is medium, and remarks is it causes delay. Next, database 3 waiting our average time is 11.0, and average TAT is 16.25, and idle time is low, and it convey effort high. Next, analysis. When the large process comes first, all other processes suffer. First come first serve is a non-primitive, so no process can interrupt other. Performance varies widely depending upon the arrival time. Next, FCFS, good for real-time system. FCFS is not ideal for the real-time system because it cannot give priority to urgent tasks. Once the long task starts, a short urgent task cannot interrupt it. It causes high waiting time when the burst time is vary. Next, it's suitable for simple batch system, tasks arriving in strict order, environment where the fairness is more important than the speed. Next, I'm going to run my code. This is my Python code. I'm going to run my code. First, we have to enter the how many processors are there. I'm giving database 1, 3 processor. It asks the arrival time and burst time. I'm going to give 0 and 5 for the P1. Next for the P2, 1 and 3. Next for the P3, 2 and 8. Here is the first come first serve scheduling result. This is the arrival time, this is the burst time, and this is the starting time, and this is the completion time, and this is the turnaround time, and this is the waiting time, and this is the response time. Next, the average waiting time is 3.33. Next, the turnaround time is 8.67. Next, I'm going to input 4 processors. It asks for the arrival time and burst time. I'm giving P1 as 0 and 10, and P2 is 4 comma 2. Next, P3 is 5 3. Next, P4 is 6 3. So this is the result: arrival time, burst time, starting time and completion time, TAT, waiting time and response time. The average waiting time of the second data set is 5.75 and 10.5. Next, I'm giving the third data set. It's also 4 processors. Third data set, P1 is 0, 15, P2 is 1, comma 2, P3 is 2, 1, P3 is, sorry, P4 is 3, 3. So here is the arrival time, burst time, starting time, completion time, TET, waiting time and response time. The average arrival time of the dataset third is 11.0 and the turnaround time is 16.25. So this is all about my assignment 2. Thank you.